So threads are single activity in the process. So threads we are calling as a lightweight process. Process is a heavy thing, so it is a lightweight. A part of the portion of the process is done by the thread. We are calling this thread as a task or program. So in order to execute a program, we have to do many things. Subsidiary activities, supporting activities you have to do for a execute a program. For example, I want to use the hard disk. I want to access the hard disk means I have to read the data, I have to write the data, I have to find the data, everything I have to do. For this, every operation I am assigning a thread to this process. So process is a big thing and threads are smaller one. So we know that at a particular instant of time, CPU can do only one activity at a time. If you take a human also, we can say that a human can do multiple things. If we go in milliseconds, he can do a particular thing at a time. So it seems to be a multi-operated person, but at a particular instant of time, you may do a particular operation at a time. So similarly, CPU also can do only one activity at a time. So since we have multiple threads, every threads have a time to do this. For this, we do an operation called time slicing. So when one thread completed its operation, so you may go to the another thread. So this switching from one thread to another thread is called thread switching. So what is the difference between process and thread? So process is a bigger one, heavyweight process and uses more resources. Thread is a lightweight process. It is a part of a process, so it is a lightweight and uses less resources. So process switching, you have to contact with the operating system. This thread switching, no need to contact with the operating system. So in a multiprocessing system, each process has its own memory, own file, own resources, etc. But in a multi-threaded, I will occupy the same area. So in multiprocessing system, if one process is interlinked with the other process, first process is blocked, second process is not able to execute further. So in a multi-threading, if one thread is blocked, other thread is free to run. So multiprocess without using threads uses more resources, and multi-process using threads uses fewer resources. So in multiple process, each process will operate independently of each other. Even though it operates independently of each other, if necessary, it will communicate with each other. That is known as interprocess communication. For example, if I want to, sometimes we will speak to the neighbor for some need. So if necessary, we will speak to the neighbor. Like this with this process. Otherwise, it will work independently. So threads are often use the same area. They will interchange. They will speak normally. They will share the same common resources, etc. So what is a thread? The thread belongs to the same process. So each thread has its own register, stack, etc. But it can be accessible by other threads also. So if a process has multiple threads, and every thread has a certain portion of the process. So each has its own activity. So each has its own registers and stack. Here, there is no need of changing. Memory switching is not take place in multi-threading because they are occupying the same memory space as well as the stack. Program counter, everything occupies the same area. So the first one is a single-threaded. Second one is a multi-threaded process. Single-threaded process has this thread has to do everything. In multi-threaded process, one is doing the program memory. It will execute the program. Another thread will take the data, read the data, write the data. This process will be done. And for the third one will store the data in a particular memory. So it will maintain the data about this particular program. That is known as file. There are two types of threads. One it is application oriented or user level threads. Another one is kernel level threads. It is maintained by the operating system. So application oriented threads are managed by the user. It depends upon the application what we are using. For example, Microsoft Word, Excel. These are applications that are running on the operating system. So when you run the application thread, so the application should have a library. It should have contained code or creating these threads, managing these threads, destroying the threads, or sending data between these threads, for scheduling, thread switching, as well as for storing and saving and restoring the thread context. So which thread is created, when it is created, so what is the operation it is done. This information we have to store in a particular area. Then only we can retrieve what is happening in the particular system. So normally this application oriented threads will start with a single thread. So after executing that, multiple threads will be created. So when you are using an application oriented thread switching will not happen. That switching will happen without the help of the operating system. So user level thread can be run on any operating system. So scheduling is based on the application oriented. These are very fast to create and manage. So multi-threaded application is not similar to a multiprocessing system. It is slower than the multiprocessing system. So kernel level threads are managed by the kernel. So here there is no thread management in the application area. So kernel threads are operated by the operating system. So all the threads are created by the operating system. So the kernel maintains the whole database of the threads. Scheduling is also done by the kernel. Creation, deletion, everything is done by the kernel. So the time taken for creation of threads and managing these threads are very slow. So kernel can simultaneously schedule multiple threads from the same process in multiple processes. So this does not be happen in application oriented. So if one thread in a process is blocked, other thread is the same process is allowed to run. So kernel routine themselves are multi-threaded. So it is advantages in running the multiprocessing system. So kernel threads are generally slower to create the threads and manage the threads. So transfer of control from one thread to another, we have to contact the kernel. It is very slow. So what is the difference between these user level threads and kernel level threads? User level threads are faster to create and manage. Kernel level threads are slower to create and manage. So here the threads are created by the thread library at the application. Here the operating system is responsible for creation of threads. So user level threads is generic. So when you use the application, any operating system, it will run. So kernel level thread is created by the operating system, so it is operating system dependent. So multi-threaded application cannot take advantage of multiprocessing. So here the kernel level routines itself multi-threaded. So here it will execute the process very fast. So far we have seen about the threads. Now we are seeing the process. What is the inter-process communication? So how the communication done between one process to another? What are the different methods which happen between the communication? So what is inter-college competition and intra-college competition? Can you tell what is the difference between inter-college competition and intra-college competition? காம்படிஷன்லாம் போனாதான் தெரியுங்களா? சபரி
சார்,
இன்டர் காலேஜ் காம்படிஷனுக்கும் இன்ட்ரா காலேஜ் காம்படிஷனுக்கு என்ன வித்தியாசம்?
எஸ் சார்.
தெரியுமா தெரியாதா? யாருக்காவது தெரியுமா?
சார் திருப்பி சொல்லுங்க, கேட்கல.
இன்டர் காலேஜ் காம்படிஷனுக்கும் இன்ட்ரா காலேஜ் காம்படிஷனுக்கு என்ன வித்தியாசம்? So what is internet? Leave it the competition. We are not going to any competition, so we doesn't know that. So we
சார்
come to
சேம் காலேஜ் பண்ணா இன்டர் காலேஜ் சார், வெளியே போனா இன்டர் காலேஜ்.
வெளியே போனா இன்ட்ரா காலேஜா?
எஸ் சார், வெளியே போனா இன்டர் காலேஜ்.
உள்ளே போனா இன்டர் காலேஜ். இன்டர்நெட்னா
சார்
இன்டர்நெட்னு ஒண்ணு இருக்குல்ல?
இன்டர்நெட்டா?
அது ஒரே கேம்பஸ்குள்ள தான் நடக்குதா?
தெரியல சார்.
இல்ல இன்டர்நெட் யூஸ் பண்றீங்கல்ல?
இன்டர்நெட் டேட்டா தானே சார் சொல்றீங்க? எஸ் சார்.
அது என்ன ஒரே கேம்பஸ்குள்ள நடக்குதா?
இல்லை சார், இன்டர்நெட் எங்க எல்லாமே யூஸ் பண்ணிக்கலாம் சார்.
அப்ப இன்டர் காலேஜ் காம்படிஷன் மட்டும் எப்படி ஒரே கேம்பஸ்? ஓகே, யூ சர்ச் அண்ட் ஃபைண்ட் அவுட். இப்போ நீங்கெல்லாம் என்ன பண்றீங்கன்னா ப்ராஜெக்ட் பண்றீங்க. ஸோ அதை வந்து நீங்க வந்து காம்படிஷன்லாம் அட்டன் பண்ணுங்க. அட்டன் பண்ணி பிரைஸ்.
சார் காலேஜ் வைஃபை இருக்கு சார், காலேஜ் மட்டும் தான் யூஸ் பண்ண முடியும் சார். அதான்
அது இன்டர்நெட்டா
சார்? இன்டர்நெட் கிடையாது சார், அதான் சார்
இன்டர்நெட்னா it is available within a certain area. Okay, internet you can connect to any parts of the network. Similarly, here interprocess means you can connect to any process in the net. So you can connect to any process in the network. So project பண்ணா மட்டும் போதாது. So we have to show our project to the outside world. So we have to attend the competition. There are some competition prizes. So participate in the competition. Try to win in the competition. So அப்பதான் உங்களுக்கு கான்ஃபிடன்ஸ் கிடைக்கும். So these are some of the steps to become an entrepreneur. ஸோ உங்களுக்கு கான்ஃபிடன்ஸ் லெவல் எவ்வளவு தூரம் இன்க்ரீஸ் ஆகுதோ அந்த பசங்க தான் கடைசியில் கம்பெனி வைப்பாங்க, இல்லைன்னா வேற யார்ட்டையாவது வேலை செய்வாங்க. சரியா? ஸோ ஃபர்ஸ்ட் ஸ்டெப் we have to do apart from study, we have to do projects, we have to participate in competitions, we have to do some other co-curricular activities other than study. ஸோ படித்தா மட்டும் போதாது இந்த காலத்தில். So you have to do some other co-curricular and extracurricular. ஸ்போர்ட்ஸ் மட்டும் பண்றேன் அப்படின்னாலும் இந்த காலத்துல வேலைக்காது. ஸோ ஸ்போர்ட்ஸும் பண்ணணும், படிக்கணும். ஸோ எல்லாமே தெரிஞ்சுக்கணும். மல்டி பர்சனாலிட்டி ஸ்கில் டெவலப்மெண்ட் இஸ் நீடட் nowadays. So okay, we'll talk in this some other class. So what is inter-process communication? So we have to communicate with other process which is available in the network. That is known as inter-process communication. So these processes are independent to each other. So normally they won't share anything with the other. So நம்மளே இருக்கோம் கிளாஸ்ல. ஸோ நம்ம வந்து இன்னொரு பையனுக்கு வந்து ஷேர் பண்ண போறோமா? இல்லை, அவனா வந்து கேட்டா ஷேர் பண்ண, இல்லைன்னா நம்ம ஷேர் பண்ண போறது. ஏன்னா நம்ம வேலையை பார்க்கறதுக்கு நம்மளுக்கு நேரம் இல்லை. So the processes are independent of each other. So that means that the one process does not share anything with another. So they are in separate memory space and they are protected by that process. So but the threads which are created within the same process will share the common space and sharing between threads will happen. So between threads there is no protection of memory data. So any thread can occupy the memory space in the process. All the threads are belong to the same memory space. Okay. So for multi-threading or threading sharing the same memory space, there is a mechanism for doing that. But communicating with the different process, we need a process called inter-process communication. So even though in the same machine, So I'm using a computer. So the computer will create different processes. So even though the processors are in the same machine, so if we want to communicate, so they will go to the process called inter-process communication. Our processors in different machines want to communicate, they have to go for inter-process communication. So inter-process communication is used to share the data, receive the data, and it will send some query and it gets some reply. These are some of the communication data. So what is the methods used for communication? So either it uses the method called shared memory or it uses the method called message passing. We'll see one by one. Shared memory and message passing. So first one is shared memory. So here, so we take a certain portion of the memory that is accessed by more than one process. So that memory is accessed by more than one process. So we look at this diagram. There is a memory area which is served by process 1, process 2, up to process n. So assume that this all the process happens in a single machine, not different machines, single machine. So normally the address space of each process are separated and protected. So when the memory is served, assume that the production is overwritten and many cooperating tasks can be happen. For example, எப்படி சொல்றேன்னா so everyone has your Gmail ID. So everyone has your drive, Gmail, Google Drive வச்சிருக்கீங்க. So it is only accessed by you. Sometimes, so I want to share the data to some other person. So I will allocate that particular file and I'm sharing to the particular person. So I'm allocating a certain portion of my memory to some other person in order to collaborate with each other. Same work can be done using the same data. So this is one person. Sometimes I will share my file to 10 different persons. Okay. So the same memory I am served by 10 different persons. All the 10 different persons are eligible to feed the data, write the data, as well as modify the data. So this Google Drive sharing is an excellent example for this shared memory. So I have a large memory drive. So I'm allocating a certain portion of my memory for shared purpose. So this is known as shared memory concept for inter-process communication. So this is very efficient and fast, but we do sharing to many persons. One of the persons is tricky, means he will change the data, he will confuse the data, and he will make the data unusable. So this problem may occur in the shared memory concept. So another one is message passing. So this message passing is known as I want a file. So I'm asking Sabaricity. I want the file. So what he is doing is sending the email to me. So this is a message passing. So I'm asking the request, he is sending the file. So the message is passed from the address space of the sender to the address space of the receiver. That is from his email to my email. So this is known as point-to-point communication. This is one of the type of message passing. Another one is broadcast. So I'm sending mails to many persons. I'm the owner. I'm sending mail to 5 different persons. So this is known as broadcast. So messages are sending from one point to many receiving points. That is known as broadcast type of message passing. Here only one sender and receiver. Here one sender and many receiver. So you are sending the file to many persons. That is known as broadcast type of message passing. For message passing, the format. So this is related to process. The sender should know what is the destination. So whether it is a single destination or more than one destination, it should know. While sending, it should specify the destination and you have to send the message. For receiving, you should know the source. So which source I have to receive, that source and message. So sender should know where the message is sent to. Similarly, so receiver should know. What are the different mechanisms used for this message passing? Message pipes and mailboxes. Mailbox, email, similarly, concept of email is taken from only mailbox. What is message pipe? It is a type of data structure. It is created by kernel. Data structure means it is a path created by the operating system. So first data what you are sent, it will receive in the process 2. So this kernel data structure, this pipeline structure, is only allowed to send the data from process 1 to process 2. So it is a kernel data structure acting as first input, first in, first out, buffer. So for writing from one end, reading from other end. So creating a pipe. So here I am sending one data. It is a unidirectional message communication. I want the data from process 1. I want to read some data from process 1. So you need only one pipe for sending the data. So if you want bidirectional mechanism, so you want to send the data and I have to receive the data. I want some data from process 1 to process 2. I want some data from process 2 to process 1. So I cannot use the same pipe for sending and receiving. I have to use 2 different pipes for sending and receiving. So one data belongs to reading and one data belongs to writing for a particular process. So former belongs to a process. The name pipe is called a system concept. When a process creates a pipe, so it will give a name as a system space. Number of pipes is created between different processes. So this is pipes. 2 pipes are created between process 1 and process 2. So you can create as many pipes between different processes they want to communicate. This is pipe mechanism. So here large number of pipes are created because in order to communicate between 2 processes you need a pipe. So a large number of processes in a system, in a machine. So you have to create as many pipes if you want to communicate with that particular process. So after the process is over, you have to delete the pipe. Then only you can create some other pipes. Otherwise, your memory space will not be possible. Second method is mailboxes. It is an indirect way of sending message. Just like a mailbox in post office. So what the sender will do means you will put a message in the mailbox. So the receiver should have a mechanism to receive it. So it is a common mailbox. So many receivers in the same locality can receive. But a receiver processors can take only messages addressed to it. So the mailbox is common to the whole system. And the operating system manages the mailbox, which is in the kernel space. But normally in the post office, what we do is I am the sender. I'm putting the mailbox in the mailbox. So it is taken by the post office people. They kept it in the post office. A particular person, postman, will separate all the mailboxes, letters. So he will differentiate according to the streets, and when he reaches the street, he will differentiate according to the and he will dispatch the letter. So here, what they are doing is here the sender will post the message in the common area mailbox. So all the senders will post in the particular mailboxes. Okay. So the receiver should have a mechanism. Should read that message. So while sender posting the mailbox, he will give a label that this particular receiver has to read, such like our address. So this receiver go to the mailboxes and it is matched with all the letters. So which letter matches its address? So it will read the data. So this type of communication is called mailboxes. So in a normal post office, postman is doing this thing. But in a process, the receiver process has to match the address. Then only it is capable of reading the data from the sender. So this is common mailbox. So another mailbox is known as own mailbox. இப்போ சில வீட்டில் பார்த்தீங்கன்னா வீட்டுக்கு முன்னாடி கதவுல ஒரு மெயில் பாக்ஸ் போட்டுருப்பாங்க, ஏன்னா போஸ்ட்மேன் வந்து கொண்டு போடுறாங்க. So this another option is has its own mailbox in the address space of the process. So it is not popular because இப்போ நான் இருக்கேன்னா 2 தெரு கழிச்சு ஒரு வீட்டில் நான் போஸ்ட் பண்ணணும்னாலும் நான் அந்த வீட்டில் கொண்டு போய் போட மாட்டேன். So I will put in the post office box only. So this way it is not popular. So they go only with the common mailbox so that every process can access it. But when it is separate mailboxes, it will take less time, but it is not efficient. So they are using the common mailboxes, even though it is slower. So it is more efficient when compared to the individual mailboxes. So next topic is task synchronization. We see in the next class. So I'll check the attendance. Stop there.